All right, let's check where we're at. I'm going to do a show of hands. If you're watching on the webcast, you can raise your hand too. The people around you will think you're kind of weird, but that's okay. How many of you think an off-path attacker can do reset injection attacks? Okay. How many of you think an on-path attacker can do reset injection attacks? Okay. And how many of you think a man in the middle can do reset injection attacks? Cool. Okay. Let's start with man in the middle. Talk me through why a man in the middle, correct, a man in the middle can do a reset injection attack. Why? Yeah? Could see all the packets, could change a flag in an existing packet, and yeah, all the traffic's going through the man in the middle, so the man in the middle can directly modify traffic. Okay, fair enough. On-path attacker. Why? Correct, yes, an on-path attacker can do this. Why?
They can see all the sequence numbers of messages coming through, so they know what sequence number to attach to a reset packet.
Good, yeah. So what does an attacker need to know to successfully mount a reset injection attack? They need to know who to send it to, okay, no problem. And they need to know a sequence number so the reset will be, reset packet will be accepted. How are they going to learn the sequence number? An on-path attacker can see the sequence numbers that are being used and so fill in the sequence number on that reset packet correctly. They could send a spoofed reset packet with a spoofed source IP address from anywhere they want, and if they're on path, they will know what the correct sequence number to put in there. So correct, on-path attacker can do this. What about an off-path attacker? So, yeah. Can't determine the sequence number. So an off-path attacker can't mount a reset injection attack because they won't know what sequence number to use. It's a 32-bit number. I mean, I guess they could try to guess it. They would have to try 2 to the 32 times. That would involve sending a lot of reset packets. And while possible in principle, we consider that a high enough workload that I'm going to just say, well, kind of not really realistic. Let's consider that not possible. Even though that's kind of a lie. In principle, if you're willing to send 4 billion reset packets, you could probably guess one of them successfully. Yeah. Uh-huh. Yeah, go for it. Yep, what's up? What's the difference between the man in the middle and the on-path attacker? Good question. For these purposes, really not much. In general, this distinction off-path, on-path, man in the middle is really important in network security. So off-path is an attacker who is not in a position to observe the traffic. So that means not in a position anywhere along any of the networks that the packet goes through. On-path means is in a position to observe the traffic, like is on one of the networks that the packet transits through. And man in the middle means can not only observe the traffic, but can actually modify it. So that would mean like one of the routers that the data is going through would be considered a man in the middle. Now let's suppose one of those routers is using a shared Ethernet to send it to the next hop. Then someone else who's on that shared Ethernet but is not one of the routers would be on path but would not be a man in the middle.